In this video, we're going to see all of the algebra that we took a look at in 3.3 and 3.4 and how we're going to apply that to finding distance from a point to a line. So to start things off, let's suppose that you're swimming. So you're this little blue dot. You notice a shark, and that line is the beach. And you want to get to the beach as quickly as possible. The best way to do that would be to hit that beach at a right angle. Now, obviously, you're not going to pull out a protractor and try to make sure it's 90 degrees. But the point is, the shortest distance from any point to a line is the length of a perpendicular segment. If you go at any other angle, you're going to go a little bit longer, and the more different of an angle you go at, the longer that you're going to take. So the shortest distance will always be the length of a perpendicular segment. So for example, if I have triangle ABC and I'm looking for the shortest distance from B to AC, I would draw a perpendicular, and the length of that red segment would be the shortest distance from B to AC. Now in the XY plane, it gets a little trickier. There's a whole lot of algebra that is involved here. And as I mentioned, we really have to know all of those things from 3.3 and 3.4. So if you needed to find the distance from point A to that blue line M, what you would need to do is first, you need to find maybe the equation of line M. You should know how to do that from 3.4, slope and y-intercept. Then you need to figure out the equation of a line through point A that's going to be perpendicular to your blue line. So take a second, pause the video, and try to find that equation. Okay, so if you did that correctly, if you found the correct slope, and I always recommend using point slope, you should get the equation y minus 5 equals 2 times x minus 2. Using perpendicular slopes are negative reciprocals and that point slope formula. Now you need to know that point where those two lines meet. It kind of looks like it's 0, comma 1, but you have to confirm that algebraically. In other words, you have to solve the system of equations where each equation represents each line. Take a minute, pause the video, review yourself how to solve that system of equations. If you went ahead and solved that correctly, you would get the point 0, comma 1. Now that was kind of convenient for this example, but that's not always going to work. A lot of times you're going to get weird numbers like weird fractions, etc. So that point 0, comma 1 is a solution to this system of equations. It's also the point where the two lines meet. So now what we need to do is figure out how far away point A is to that point where those two lines meet. Well, we use that distance formula. So plug that into your distance formula. And then if you reduce everything, you should get the square root of 20. So that's a little bit more than 4, not quite 5. So that's the distance from point A to line M. So just to recap the process that's involved, here are the steps. First thing you need to do, you need to find the equation of a line through the given point. They'll always give you one point and one line. You want a line that goes through that point and hits your given line at a right angle. We should know how to do that from 3.4. Then you need to see where those two lines meet. What that means is you have to solve a system of equations. We should know how to do that. We reviewed that the first week of school. Thirdly, you've got to use that distance formula. So make sure you use that point that you found in step number 2 and the given point from the very beginning. So it's a long process. It's 3 big steps. It's a lot of algebra. So make sure you're familiar with all those techniques and you should be good to go.